Do I have everyone down that's here in the attendance? Have I gotten everyone? Oh.
Talbot voted?
Did I spell that right?
Yep.
Okay. All right.
100%.
Okay.
It depends on what, that's my past one. And then you're gonna have like expected, well, this is just for me to like, as a voting zone. So I was expecting mixed by that, and then I had
What was last week?
No, I'm already in.
Oh,
I have that, but,
I'm.
so
Yeah.
either mixed,
I don't know if.
maybe I'm not expecting or something.
Yeah. This is a lot because I did not know as that many people were going to show up in person because I didn't know Dr. Veros was only going to offer the participation point if you came in person. So this is just it specifically said when I reserved the room max 12 people. So I mean,
we can double that.
if you guys want, if you don't want to be suffocated in here, you can go on the Zoom or whatever outside. But if you want to stay in here, I'm not going to stop you. Hopefully nobody comes by and is like, "What is going on in here? Like, why are there 24 people in this tiny room?" Okay.
We'll just tell them mind their business.
Yeah. I think all of those people are
Incoming.
maybe. Okay, great. Okay. All right.
I'll leave for an extra 20 now.
An extra 20 participation points? I think you only need 10, right? Or is it 20 now? I don't know.
It's 10.
It's 10?
Like you said, an extra simulator.
Can you get extra credit for more?
I don't know. You have to ask them.
I'm not sure. I'm being here.
Just like
Everyone
the one that told me.
who's new, I'm very sorry. I didn't know he was going to only offer participation points for in-person people. So I did not think that many people were going to come in person. So this is a tiny room. All right. I might just go honor system for attendance. I don't want to spend 10 minutes doing attendance. So I'll trust you. Please don't abuse that you came if you say. Okay.
How do we record that we came?
It should be like on the participation point assignment, like what events did you go to or whatever.
Spreadsheet for wanting participation.
Yeah,
Cool.
it's something like that. If he hasn't changed it. Okay. Let me make sure I'm unmuted. It seems like there's only one person in the Zoom. Okay. So I have some content planned to go over, but we can also just do a question hour. It's up to you guys what you kind of want to do. If you want me to run through what I had planned, but we can also just do questions as well, if that's something you guys want to do.
What do you have planned?
I was just going to go through some basics of C, some pitfalls, kind of better ways to do things, some basics of make files. That's probably going to be the build system that you guys will be using for all your labs and I think also programming assignments. And then, some Linux stuff as well at the end.
I think that should be good.
Let's do that?
Yeah.
Okay.
He said the main point of this was to meet you, so what was your name?
Okay. Spencer. Sorry, guys. I'm Spencer.
I also had a couple of questions. You took the class before, right?
Yeah.
So I'm a little lost of like just going into it.
Mhm.
Like, is there like a structure of like stuff we're reading, or we're just going with the flow of like day-to-day stuff? Because I know, like he said, like we should be prepared doing like the readings ahead of
Yeah.
time, but I haven't seen too much of like. I mean, I get into the syllabus, but like,
Right.
how can we prepare better? I guess.
With Dr. Veris, it's very much you go with the flow. fortunately and unfortunately. Homeworks will usually be the readings, and homeworks will usually, have you read something, and then hopefully the next labs or next programming assignments will be sort of related to what you have read about. So I think the first homework is about like instruction level parallelism or whatever. So I'm guessing you'll have to do something with SIMD for this first lab, hopefully. And if you don't know what SIMD is, hopefully he will explain that. And if not, I'm open to explain always. Does that answer your question at all, or is
Oh, yeah, for sure.
Okay.
Yeah.
Okay.
I need help.
Yeah, that's what I'm hoping. I took the class and it was disorganized, so I want to make sure it felt disorganized to me a little bit, so I want to help everyone and maybe give it a little bit of, yeah. Okay.
What software do we need to have?
You definitely need some place where you can develop on Linux, so you need access to Make, GCC. You'll get into MPI, which is just like a kind of library or framework for doing distributed programming across like many nodes or whatever. Hopefully he'll explain that as well. If not, ask me. So definitely need Linux, GCC, Make. You can do all that stuff on the GPELs. I would recommend either, if you have access to it, I'm sure he said already, getting your own Linux machine or using WSL, which is Windows Subsystem for Linux or something like that. And that's just let you have like a little Linux machine, little virtual machine, Linux virtual machine on your Windows or whatever.
I've been having issues with that
Mhm.
myself. Have you had any experience like so far
I-
trying homeworks or previous TAs studying there?
I've always been on Linux, so I've never had to
Okay.
do WSL. I mean, what is it? What's the issue?
It's just weird. I mean, like if there's like a better IDE, I'd much rather
Mm.
work with that than Windows, whatever they got going on.
I mean, I know a lot of students in my previous class did the VS Code remote SSH.
Mhm.
That seemed like the most sort of ergonomic way to do things in their experience. But I think the best way is just keep it all local to your machine if you can. Just get Linux. You might as well get the experience now because a lot of software engineering is very centered around Linux in the first place. So unless you're doing like game dev or whatever, then it's Windows. But if it's anything else, it's mostly Linux based. So you might as well, while it's low stakes now, get used to it if you can. Are there any other questions? Okay, so we'll start by just going a little bit over C. Is that pretty visible to you guys? So I don't know why it like looks different. Let me just go over here. So it's exactly the same. Okay. So are you guys worried about pointers at all? As I go through, make sure like if this is something you already know or whatever, stop me and we can move on or whatever. But let's just start from probably the scariest part of C, it seems like to people, is pointers. So we'll just start with just some basic things here. What you would think would be basic is just we're declaring a variable x that's an integer, and we're going to say what is the value of x. And hopefully, what is it called? Oh, I'm in the wrong. Sorry. Sorry. Oh, it's me. Sorry, guys. I wanted to have more of this prepared, but I thought I would have a little bit of time at the beginning to prepare, but that's all right. So we're going to compile this file, which is main.c, with GCC. I'm putting this -G flag to say keep all the debug information. That'll be more important later, but it's just saying in the final executable, the final machine code, keep some extra information in the actual binary or whatever. -O says what do you want the actual program or the executable's name to be. So we're just going to call it program.x. So we compile it, and then we'll say running the program. If you're running a executable that's in like a folder or whatever, it's not part of your path or whatever, you always need to prepend it with // and then the executable's name to run it on Linux. So we'll run the program, and that seems correct. That seems like what we expect. If we say a variable x is 1, and we say what the value is, it's going to say 1. Does that seem okay so far? Okay. So now we'll do a little bit of pointer stuff. So what do we know about pointers? What do we think that they are?
Like a reference, right?
A reference.
Yeah.
What it is just an address in memory, and so we'll see that. So if we say what the address of that is, we recompile, we do that, we write the file. We say the value of x is 1, the address of x is blah, 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 whatever hexadecimal number it is. So that's all a pointer is just an address. So if you ever want to take the address of a variable, you just prepend it with the ampersand or the and symbol. And if you ever want to say you have a pointer, which is an address, and you want to get the value at that address, then you'll put a star at the front here. And that's called dereferencing. You're dereferencing the pointer. And that'll get you back the value. Is this too basic? Or is this helpful to go through?
Good refresher.
Okay. So it's exactly like we expect or whatever.
And then, sorry to
Yeah.
be
No,
back
don't,
there.
not at all, not at all.
Okay. It's been a minute. So
Mhm.
when we're doing that dereference piece, we're pulling the value, not the address, correct?
Right. So if you want to pull the address of a variable,
Just without the star, right?
yeah, like so like if we say remove that,
Mm-hmm.
obviously it's going to throw an error or it's going to have a compilation error or whatever. This is now just an address.
Gotcha.
Right. But if we want to pull the value out, we dereference with the star.
Cool.
And if you want to say, this is kind of a what you want. Some people will do this to say you have a pointer to an integer. That makes more sense to me, but the only issue is like, I don't know if this is going into a rabbit hole or whatever.
I was gonna say the syntax of like either or doesn't matter when it comes down to like compiling.
Not in this case. So I'll show you an example where it does matter. So say you can declare multiple I wouldn't recommend ever doing this anyways, but you can declare multiple variables of the same type. You say, I'm going to have an integer that's called blue and I'm going to have an integer called red. That's completely legal or whatever. What if we want to say, oh, I want 2 pointers? Are they both going to be pointers? No. Only the one that has its, the rightmost. So if you want, that's why. It's just a weird C thing. Obviously, this language was made in 1970s, so you have weird things. So this, I find, is just, it's more accurate to what it really is, even if it makes a little less sense conceptually. Okay. So now you've probably heard like null pointer dereference or like how that's very bad or whatever. So we'll see a little bit of that now. Let me re-comment all this stuff. Okay. So if you dereference a null pointer, it's not very good. Segfault. So if you've ever heard of like segfault or whatever, that's like usually the only error you're going to get if you have an error or whatever that crashes your program in C. There's no like stack unwinding or things like that. So, and the issue is that segfault can mean like a lot of different things. It could mean you've accessed out of your array bounds because there's no bounds checking in C. It's very much like riding on a motorcycle. They're going to trust you. That's all right. So null pointer dereference, try to avoid it. Usually that would be something like, oh, I've asked for memory or whatever, and I actually didn't get back memory. That's a bad thing to happen or whatever. But that's one sort of non-trivial case where you would want to be checking for that. So a really helpful sort of idiom that you can remember is to just always check if you're, well, not always, but if you're very worried about, oh, could this pointer ever be null, just check. And then if it's not null, do something, or you could have an early return, whatever, just make sure that the pointer is not null. If that's something that makes sense in the program's control flow or whatever, so that a pointer could potentially be null at this point or whatever. And then another cool, maybe not cool thing, but I think it's cool. In C, conditionals are always, there's no bools, there's no Boolean values in C. The conditionals are always, is this thing equal to 0? Then it's false. If it's anything else, it's true. So if we remember that a pointer is just an address, if the pointer is real, is an actual address, then it's not going to be equal to 0, because if we look at what is null, if we go to the definition of null, it's just some weird syntax around a 0. So by checking, hey, is the pointer, if we go back, is the pointer here, is the pointer anything but 0, it's the same thing as saying, is it not null, if that makes sense. So if you see code that looks like that, it's doing the same thing.
This is a stupid question, but like, I mean,
No.
we use null to
Mhm.
represent 0.
Mhm.
Why just put 0?
I don't know. I don't really know. I think maybe to give it a little bit of extra
it looks good,
semantic,
yeah.
extra semantic meaning, but it's, you have to go back and ask, what's his name, Brian Kernighan or Dennis Ritchie, whoever made C. I
I'll
can't
go
remember.
back and ask Turner if I have to.
Yeah. All right. Arrays. Arrays. That's basically the most important thing you'll probably be dealing with in this course. I tried to structure this around stuff you'll actually encounter in the course. So an array, you've probably seen that in many other languages. It's basically the most common thing you'll ever see, right? So if we have an array and we want to iterate over the values of the array, we can do something like this. We compile. Actually, I'm going to comment this out first. Okay, makes sense. Like if we go back to the code, 0, 1, 2, 3, 0, 1, 2, 3. Okay, but what in some languages, array is like a distinct type. It really means something. There's some sort of semantic meaning that is actually embedded in the code about that or whatever, if that's not a confusing statement. In C, arrays are just syntactic sugar, which means it's not really real, around pointers. An array and a pointer, the exact same thing when you compile it down into machine code or whatever. It's the exact same thing. So if we print the value of array, or if we,
Isn't it just the pointer to the first element of the array?
Exactly,
And
yeah.
knows to go to the next one from that
right,
point?
right, exactly. So if we recompile and we say all these things, we say, okay, the array's elements are this, and we say, what is the value of the array? We get another address, another hexadecimal thing. Because an array and a pointer in C, the same thing. That's probably one of the biggest mistakes of C.
Because array is just like a section of memory just to store all.
Right,
whatever
contiguous memory
Okay, got it.
of in that each element is the same size.
Okay. And that hexadecimal code is
Mhm.
that section of memory.
It's the very first, it's the address of the very first element.
Okay,
Does that make sense?
Yeah, yeah.
Okay.
So like in some languages, when you pass arrays to different functions, you
Mhm.
use pointers, like you can't do that in C because the way the memory addressing is set up is pointing to the variable.
Right, so like when you can pass arrays to functions, it's just going to decay, that's what they call it, decay into a pointer to where you're just saying, here's the very first element in the array, if that makes sense.
Yeah.
So a common thing, we'll get into it later, but a common thing is you'll pass the pointer to an array and then the length of the array to a function.
So that goes into like the sorting stuff too, right?
Right.
Got it.
Okay. So what if an array is just a pointer, what does the array do? What does the syntax sugar actually cover? What does it actually give us? So if we go here, has anyone ever heard of like pointer arithmetic? Does that sound familiar? You might have heard it offhand a little bit. all the C kind of language does is it wraps this syntax here, exactly wraps this syntax here. It's just a nicer way to say that. So what are we doing in the pointer arithmetic thing? We're saying take the pointer to array, the address at array, at the whatever that address is, add I. What does that mean? The compiler knows the size of an integer. When you add to a pointer that's typed, like a typed pointer, the pointer has a type, like an integer pointer. When you add whatever number, it will add that number times the size of the type. So for an integer, most times it's 32 bits. So if I is 0, it's going to add 0. If I is 1, it's going to add 1 times 32 bits. And that will give you the address of the next element. Does that make sense? Okay.
So just for syntax, like from what I remember with C, like if you want to like say like you want to multiply this thing to the next thing, and, like if it's in a loop, you can do star equal.
Oh yeah, yeah.
Can you do the same thing with that without getting confused between the syntax?
Yeah, like if you do something like
Like if you want to multiply, keep on multiplying, whatever.
like where you do like the star equals and it multiplies and then puts
Yeah.
it back in. Yeah, that'd be fine. I mean, I wouldn't know the exact.
I was like, I
Oh
can
wait,
see-
no, I'm sorry. This that's another thing. This star here is the dereference. It's not multiply.
Oh yeah, okay, yeah.
So the dereference you can't. It's not like something you go star equal to dereference the thing on the left.
Mhm.
Star equal, again, confusing. Star equal will only do a multiply and then store it back in the thing.
Okay, so as long as we make that space for sure for the compiler, like, hey, we're trying to dereference this
Right.
at the same time multiply it.
Right.
Okay, gotcha.
So that's the same thing. So we're saying, okay, increment the pointer. Oh, good.
No, I was like, yeah. I get
Okay.
it,
Increment the pointer by whatever, and then dereference. That's all the, square brackets I is doing exactly that. Okay. And then we can verify that real quick. Wait, if I write the file. If I write, oh. I see. What? Oh, I'm stupid. It was doing that. I'm sorry. Yeah, you can see that they're both equivalent. If we go back to how this is saying, are they equivalent here? And they both are. Okay. So if we go into functions, that's a pretty fundamental thing about most programming languages. There's, oh, go ahead.
Can you do something really funky with the pointers if you have different types that are of different
Mhm.
sizes, and you have like a pointer to a smaller size object, and you increment that pointer?
Mhm.
Will it like move? So you have like a double after
Mhm.
a 32-bit integer. Will it like just
Like you
yeah what
like having an array of different types?
not an array of different types,
Mhm.
but like say that there just happens to be like a double
Mhm.
directly in memory after an integer.
Mhm.
Will it?
Oh yeah, there's no bounds checking at all in C. So like if you say it
Well, can you-
depends. So
Will
if
it-
there's
will it give you like half of the bits of that double?
Yeah, will it truncate it?
You'll get the front
You'll
half
get-
if the pointer.
yes, so it depends. If the memory that's like directly after it has been given to your program, yeah, it'll just kind of print out and interpret it how it thinks it should. If the program that's like directly after has not been given to your program by the operating system, it'll be a segfault. Does that make sense?
Yeah.
Okay. Okay. Okay, so functions and arguments. Probably two main things you need to know. Let's just start basic though. So this is pretty simple. We're going to have a function named multiply and add numbers. And if we go to the definition, pretty simple. We're just going to say the result is equal to this variable accumulate plus x times y. And then we'll return the result. So that's pretty basic. Basically what we expect hopefully. 6, so it's going to be, if we go back here, 0 plus 2 times 3. That's what we got. Okay. So when passing things to functions, you have to be very mindful about what you're trying to do with the thing you're passing. So if we say we're going to have a value and we're going to pass it to this function, and maybe in the function we want to modify the value. We want to say, we'll set this value to negative 9,999 or whatever. Do we think that that's going to modify the value that we have, this value that we've allocated here? Well, let's see. Pass by value is 100. Well, how does that make sense? If we pass this value and then we set it equal to negative 9,999 or whatever, why is it not reflecting that in our, our print statement? Well, it's because when you pass any thing to a C function, it takes a copy of that thing. So if we pass value, which is equal to 100, the function gets a copy of value, which is 100. When we modify that copy, it's obviously not going to be reflected in the outer scope where we allocated that initial value variable. It's going to be only reflected within this function because it has a copy.
Because it's touching a separate reference.
Right. Okay. So if we want to modify some value or whatever from within a function, we need some way to say, hey, do you know this, value? I want you to reach in there and change it in some way, if that makes sense. So if we remember that, hey, this is a computer, and that all these values have spots where they're always going to be, they're always are going to be memory addresses. If we pass the memory address, hopefully, that will allow us to modify it. Okay. So if we go back here, we say pass by pointer. So we say take the address of value, and we pass that in, and then we dereference value. We say the actual thing at value, we're going to set that to negative 9,999. If we do that, hopefully, that gives us what we want. And that does. Because when we pass that address, we're saying, hey, do you know this location in memory? Go actually modify that location in memory, because the function received a copy of the address. And since we're not actually modifying the address, we're modifying the thing the address is pointing to, then we're okay. We're modifying something that we can actually modify from what we have available to us in the function. So a helpful thing to remember, if you're actually trying to modify something, pass a pointer to it to a function.
Okay, just to make it clear, so so we're passing by the value.
Mhm.
It gets a copy, a totally different address.
Mhm.
But when we send it to this point by value, it's telling that copy, hey, go get your original stuff, and then
Right, it's receiving a copy of the address, but the address is going to be the same
Yeah.
no matter what. You're
and
saying,
then that's when we change the stuff that's inside.
right. Does everything make sense mostly so far? Okay. That's what I was hoping. Okay. So you've probably heard of like stack and heap and all these things. What happened here? I might have. Oh, I'm stupid. Sorry. I gotta. Let me actually turn off diagnostics because it might spoil. Okay. Uncomment this. Go back here. Okay. So say we want to make an array or whatever, and we want to initialize every single value with 10 or with whatever we pass in or whatever. And we want to just return that. We want to have a little helper function that does that for us or whatever. It's not a bad idea, right? But the issue is, if we do this, if we say, what's in all these things, pay no attention to that warning because it spoils, but we're going to get a seg fault. Does anybody have any idea why? Yeah.
The array only existed in the function.
Right, exactly. It's in the function stack. We're trying to return memory that was allocated within this function's stack. So when that function ends, all that memory gets pushed off the stack, and we no longer have access to that as defined by the operating system. And so, you have to be, usually most times IDEs or whatever development environment will have like little diagnostic help like this where it's going to say something like this, but I just want to throw that out there just in case.
What are you using right now?
NeoVim, if you've, yeah. All right. I'm going to re-comment this out because it's going to throw a warning every time I recompile. Okay. Let's go back here. Re-comment this out. Okay. So a common idiom that I kind of touched on earlier for passing arrays to functions is you kind of want to think of them as like a slice. You're passing, if you've like programmed in like Go or whatever, a slice is a pointer to the first element and then the length, how many elements are in the array. You just have to do that always in C, if you want to be safe. So oftentimes you'll allocate the array, if you're using a stack array, in the scope that you're actually going to be using it in later. So if we're going to use it in this scope, we want to allocate it in this scope if we're using the stack. Does that make sense? Okay. And then a good thing to remember is that if you're allocating a array on the stack, so if it's like it looks like this kind of, you want those arrays to always be of a length that's known at compile time. Because you could have, even though C allows you to have variable length arrays that live in the stack, you can have stack overflow, if you've ever heard of that, where you allocate a humongous array on the stack and it's going to crash your program or whatever. So try to have reasonably length, compile time known arrays if you're allocating them on the stack, if that makes sense. Go ahead.
Yeah, so let's say we've got a file that has like ungodly amount of numbers and rows and columns. We can essentially, I can't remember, we can pull out, let's say, I want to read off this column with X amount of like whatever digits is in there, and then call that function, like that's going to be my length for that. If it doesn't fit for whatever reason, then it could be an error. Should be an error. Right?
So like having like a statically sized buffer that you're pulling stuff into.
Yeah, because like I don't want to be hard coding this all day.
Right. That's another common thing is you'll have like a. I prefer this. You can go the route of like if you've heard of like heap or memory allocation, malloc. That's one way to deal with variably sized problems. In my opinion, that has issues or whatever. I much prefer just allocating a big power of 2 array and just saying this is going to be the max ever. And then if the max is too small, well, then you can change that while you're actually developing the program and not, hopefully.
I was gonna say, would you say we would go too deep if we're like allocating individual cores? Like, is that too much, or
Like, what do you mean
like
by?
I don't know, it's parallel?
Oh yeah, like threads and stuff.
Yeah. Is that too far? I don't know. I feel like that's
The operating system will allow you to allocate like 400 threads or whatever, but obviously it's not going to be scheduled by the operating system. Like on each, if you only have 8 threads, it's going to have to do a whole lot more work to schedule all those things, if that makes sense.
Yeah.
Okay. So if we do this, we pass this to the function. We'll pass the pointer because remember, an array is a pointer. So we can pass the array, even though when we declared the array we had the bracket syntax, it will decay into the star syntax. And then we'll pass the array length, and then whatever business the function is actually doing to the array. So if we do that, should work okay. Yep, looks like that works. Okay. Right. So dynamic allocation. This is definitely, again, I'm just going to do what's going to happen in your assignments probably. So this is most of the time what you're going to deal with. So as we were talking about earlier, even though we know the length of this array at compile time, because this is obviously, it's all constants, that's going to be known at compile time, what the array length is, it might not work. We'll see. Segmentation fault. Why? That's too damn big. That's 10 megabytes, right? I think. That's a little big. I mean, most times your stack, I think the operating system allocates like 8 or something like that, I think. 8 megabytes for your stack. So we can do something a little different if we actually use the C standard library for actually requesting more memory from the operating system. That's mostly, mostly, it's done with this function here, malloc, memory allocate. So you're asking the operating system, or really, you're asking the C standard library to ask the operating system for memory. So when you do that, you pass how many things you want, and then the size, well, this is the common way, the size of those things, or whatever. But really, if we look at the function signature, it just wants the size in memory, allocate size bytes of memory. So a common thing you'll see is like however many of things times the size of, which is going to give you the size of the type in bytes, if that makes sense. Okay, so if we do that, we get this really long program, blah, 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 blah. I'm not going to let it run the whole time, but we do that, and it looks to be correct. We actually got the memory that we requested.
Since you cut it off, did the free run?
That's something I'll talk about. So most people tell you always free your stuff, and that's a good practice. Honestly, you probably should do that. But the operating system is pretty smart. It knows what memory you've given it, and so when your process ends, the operating system is like, I'm going to reclaim all those resources that I know I gave you because I've been doing bookkeeping about your program.
So if we were on like much older systems, that would be a worry. But like,
I don't know. I want to say that this was a pretty. I don't know actually. You'd have to look at the history, like Linux or Windows, to see when they added, this more. I wouldn't say advanced, but more rigorous bookkeeping or whatever.
Maybe in embedded systems, we have to definitely use free because
Right.
Because it's very small.
Right. Right. Exactly.
But in our laptops, it's okay.
Yep. So the only issue is like, you imagine you have a program that's running a server or whatever, and if you're constantly not freeing things, and this program is running for months at a time, that's when you run into memory leaks or whatever, where you're not freeing memory that you requested, and the program is also not ending to allow the operating system. So it's good practice to always just free, just so that when it actually does matter, you remember. But most times in small programs, I don't bother, but do as I say, not as I do.
When you say like memory leak, are you saying like the memory leak just applies, like does that term only apply to things that aren't free, or is it also like you lost like things that are free? Like, what is?
It's kind of like one of those words that is just expanded to capture more things. When I think of memory leak, I think of you're requesting memory that you never give back to the operating system that you're also not using, if that makes sense. Like you're asking for memory, you're like, oh, I'm done with it, but you don't tell the operating system I'm done with this memory. That's what my mind thinks of when I think of memory leak.
So that'd be like optimal with your memory, basically.
Yeah. Okay, so strings. That's another very basic thing that every programming language should have, and maybe C has one of the worst ways to do that. So char, if you think about what is a string is, you would think it would be like, oh, maybe it's an array of characters, right? You'd think, because that would match the rest of everything else. You'd think, oh, if I have a list of numbers, that's an array of integers or whatever. A string in C is a pointer that then has, at some point, a 0 at the end of that list of characters or whatever. It's not a length. You don't pass a length of the string. It's just the pointer and the string just goes until you say, here's a 0, that's the end of the string, if that makes sense. It's not the way maybe you should do it now. Most of the times you would say, here's a pointer and then a length, just like you would want to do that for all arrays or whatever, but that's the way it is. So we're declaring a string, which is really a pointer to a series of bytes, and C has this little syntactic sugar to, have that, where you're not saying the value of pointer at 0 is H, the value blah, blah, blah. So we have that, and we say, here is that message, exactly. And if we go, I just thought this is not really super related, but I just thought it's very interesting. If we go to the actual executable, the binary file that the compiler generates, that string will be in here. If we search for hello from the code's data segment, that string is in the actual binary file that is made by the compiler, which is, I think, is very interesting. So, and a lot of like every constant value is going to be just baked into your program in a compiled language. Okay. Cool.
So you said it just like goes until it finds a 0, right?
Right.
What if you have a 0 in your string?
Then the string ends exactly there. So if I put, that's actually, I didn't think of that. That's a very good.
It doesn't get escaped by the language when you're in the.
So if, I bet if we do this,
Because like, is 0 a character at that point, or is it?
it's if you like
the
look at the
sensible
memory,
number.
it's like literally just a 0.
Okay.
Yeah, it's gonna look at the next byte, and if it's all zeros, like all 8 bits are 0, then that's it. If that makes sense. Oh wait, whoops. Not that. See, if we terminated the string early here, and then when we print it out, that's a very good. I should have thought of that. That's a very
But that's because you did the \0 though, right?
the backslash. I think if you do a 0, it's going to interpret that as the character, the ASCII character 0, which is like 32 or something like that.
If you wanted to use \0, maybe we need to use another backslash.
I was gonna say, isn't that the same?
Oh yeah. If you like escape, you can escape an escape, if
Yeah.
that makes sense.
But isn't that the same thing as like the doing the \0? Is that
Mhm.
the same thing as like \n? Because like you're ending the sentence.
Backslash n is another ASCII character. It's like carriage return or something like that.
Yeah,
It's
so
got
maybe
it's like
I think of
13 or
null
something.
is-
Yeah, no, exactly.
Yeah, okay,
no,
yeah.
no. Okay.
Because like, is it Java that does that? Like you have to end the sentence with like inline or whatever.
I have no idea. I'm not sure.
Because it just kind of reminds me of that. You
Yeah.
like end with a 0.
Right. Okay. It's not going to let me do this. I wish it would just let me compile and show you, but since this is a const char pointer, const string, it's not going to let you modify that, because when the program generates your executable, there's going to be a segment of the executable file that's going to have a label, and it's going to say read-only memory, and nothing in that segment, that data segment or that memory segment, is going to allow you to modify it during your program's runtime, if that makes sense. Okay. Recomment all this. Okay. Let me redo this. And this is another way to show that, is that you can fool yourself. You saw how like my editor kind of warned me. You can psych yourself out and say, oh, I'm trying to cast this or whatever, and then I'll modify it. Maybe if I try to trick the compiler and say, hey, I'm not going to modify this memory through this whatever, I'm going to modify it through my own pointer that maybe the compiler won't catch. And the compiler won't catch it. Oh, whoops. God damn it, I keep doing that. Whoops. The compiler didn't catch it, and then we had a seg fault because we're trying to modify read-only memory, if that makes sense. Okay.
You can't modify strings at all?
You can, like if I declare this non-const, then the compiler will not put that in the read-only segment of memory, if that makes sense.
So as you say, it's like it's being baked in.
It's baked into the program.
Right.
Even if it's not const, it'll still be baked into the program, but it'll be in a different section of memory.
Okay.
Of
Kinda
the
like private and.
yeah, exactly. Kind of. Yeah. Okay. see. Yep, I talked about that null terminated string. You'll hear that a lot. So if we do, can't even remember what this one was about. This is kind of a little bit about that there's no bounds checking at all, and especially for strings as well. If we want to say, hey, just print out this high string, which remember, array is a string, or array is a pointer, so we can do kind of the same thing. Obviously, if you do this, you have to be mindful and remember, I need an extra null character. But if we don't do that, if we forget that, which if we go back up here, I just want to maybe say that as well. This syntax here, where it's the double quotes, is just syntactic sugar around this that also adds a null character at the very end. Okay. There's lots of syntactic sugar in basically every language, but kind of a lot of it in C. Okay. So if we do this, you might expect naively to say, oh, it's only going to print stack string is high. If we do that, we get stack string is high, XXXX or whatever, and then because our stack ends after that, the next byte in memory, because all the memory that the operating system gives you is zeroed out, it gets a null terminated, even if we don't add it, if it's the very last thing in our program stack, if that makes sense. Okay. So always remember, just don't do that. Just use the double quotes. But I think it's helpful for learning like what all this means. So yeah, this is how you would want to do it. And again, this is something where you could actually buffer up, say this is the maximum amount of characters I'm ever expecting in a string. I'm just going to allocate that and I don't have to worry about it. And then blah, blah, blah. You get the idea. I guess we can run through it just in case. Okay. What we expect. Okay. String literal, this is kind of repeated. Works the same when you buffer it up, blah, blah, blah. All right. You can also, if you want to do, again, I wouldn't recommend it. You can also, allocate a string off the stack, or off the heap. Excuse me. This is another way you'll often see memory allocation being done. Calloc. I think it stands for like counted alloc, where the first argument is the number of members, the number of elements, and then the second argument is the size of each element. And that'll, if you use the IDE and gives you function signatures, it'll tell you that. But you'll see some of that. So we have this. We then need to memcopy this string back into the buffer that we've allocated. Because why would we need to memcopy? Why couldn't we just set message equal, or heap buffer equal to message?
They're not values, they're points.
Exactly. You're just saying that the pointer to heap buffer is equal to message. Now you no longer have access to the heap buffer because the heap buffer is just a pointer in memory, if that makes sense. So, all right. We memcopy. This is basically the same thing. Oh, and I guess I should say strlen, because the length of a string is not coded in the type or whatever. You have to call this function strlen, which is basically, it's exactly what you think. It just iterates, and once it finds a 0, that's the length. It just increments or whatever. Okay. Yep, works just fine. And then remember to free, always. Okay, structs. So let's say you have heterogeneous type. So like maybe an array is very good. If everything is the same type, that's very good, use that or whatever. But maybe you have something different where there's different types that you kind of want to conceptually package together. You might have seen like classes in other languages or whatever. Struct is sort of the same thing. Obviously, class has the connotation of you have functions that are specifically tied to the class or whatever. A struct is just a group of data. There's no functions that are tied to it. It's all just collection of heterogeneous data, if that makes sense. So sometimes you'll see this done. I don't prefer it, but you'll see people make their own like slice structs where it's just a pointer. If we go to the definition, let's do that first. It's just a pointer, and then the count, the length of the array. Obviously, the issue with this is that if you wanted to do this for every single type, there's no generics in C. You have to either manually write this or write yourself a meta program that will generate all the array types that you want or whatever. So it's kind of, I think it's more simple to just, know that you're in C and just pass pointers and lengths always, instead of wrapping it into an array, a struct. But you'll see this sometimes. So we have this thing, we do something with it, I can't even remember, it doesn't really matter. Something that you'll notice is that you can't, if you declare a struct type, like this, here, whenever you want to reference it, you have to prepend it with struct. So that's one way to do it. You can also do something like this. I just want to throw it out there. Oh, whoops. You can do type def. So you're defining a new type as a struct array slice T, which is this right here. Reformat this. Defining this type here, this struct, as this thing here, if that makes sense. And then you can use it like you would expect in other languages when you define your own type, if that makes sense. It's just goofy things that are just baked in, I guess. So if you look at the Linux kernel code, they don't allow any of this type def type stuff. It's always, if you're passing a struct, it's always struct blah, or whatever. So interesting enough. So we do that. Let me go back here. Okay, so we do that. There's something kind of neat about C is you have designated initializers where you can declare this member of the struct is equal to this member of the struct is equal to this. You can also do the thing where it's like implicit, you just have commas, like you're almost passing it to a function. Same thing works. I think this is more clear though. So we do that. It's kind of what we expect, hopefully. Okay. We're getting close to the end of the C part, hopefully. Okay. So file handling, this is another important thing. I think you guys will have done a little bit of this in your first assignment, if I remember correctly. Okay, so it's a little bit more primitive than maybe Python, the way you interact with it, but you say, this is again a standard library function. You file open fopen, the name of the file, and then this argument right here is the mode of reading the file. If you're writing to it, if you're reading to it. There's a couple other flags you can pass, like if you're reading it, you're interpreting the file as a binary file versus as an actual text file. There's a couple different things, but most of the time you'll just see fopen, comma, R or W if you're writing or reading, respectively, or opposite. Okay, so here we're doing another thing where we're actually buffering. We're saying probably if we go look at the actual file input here, we're assuming we're never going to go over 256 characters in a line, because that's what fgets does. It returns to you a pointer to the very, it actually modifies. I believe it also modifies. I'm struggling to remember here, sorry. Yes, I believe it will modify, actually, how does that make any sense? I don't know, let me make sure that this is actually correct. Okay, I can't remember, I'd have to go look at the documentation, but it returns to you the next new line terminated string. So it will iterate over the buffer or over the file and say, okay, are we still in the same new line? Once it hits a new line, it will return to you the pointer to the beginning of that line, if that makes sense. So this is how you'll often see people do like file handling or whatever. You'll just go line by line, fgets. And we're taking advantage again of that. Every conditional in C is just checking if it's 0 or not. So this returns, that's why I'm confused. I believe it also it will modify your buffer pointer, I think. No, I'm sorry, I'm stupid. It fills the buffer with that new line terminated string, and then it also returns the pointer to that string, if that makes sense. If that makes sense. Okay. So we're saying while fgets is returning an actual valid pointer, it's not returning null, because it will return null when you have no more new lines in the file. So, if that makes sense. So, we already kind of ran through it. Does that make sense, or is that kind of confusing?
So essentially, it reads the line based on the buffer
Mhm.
and assigns it to the address where it's being read to?
Yes, so the file that you kind of notice that it does not look like the rest of the types that we've kind of interacted with so far. It is actually not part of the base language. File is provided by the standard library. So it's an opaque type, if you've ever heard of that. So on the internals of the C standard library, it's keeping track of where you are in the file. Does that make sense? It's kind of like, it's like a stream. If you've ever used a stream in other languages, it's basically a stream, if that makes sense. So it's keeping track internally of where you are, and every time you interact with it with any of these f star functions, it's going to increment by whatever.
That's why we don't need to know where we are in the file.
Exactly,
because
right.
Something else is keeping track.
Right, exactly. And then, this is actually a little bit more important to remember to close your file handles. Okay. So the same thing works if we're trying to write a file. We'll just say fopen with the name of the file we're wanting to write to, and then W. And we'll do the same thing. If we do that, we'll get no output, but we should have an output.txt, which looks like it matches. Cool.
If there's no file, it creates it.
Yep, exactly. I think there's an option to say don't do that, but I can't remember what it is. And usually if you have an option like that, it will just be another character that goes here. Like it'll probably be like something B or something like that. Okay.
Is it overwrite with the file? Or
Yes, it will. Like if we go, actually do that because I think, I could be wrong, but I'm pretty sure. Like we change the file to say fiddle,
We won't have both lines, we'll just have the one line.
right? Maybe.
Like, file.
Oh, I'm stupid. Yep, there we go. Yeah, it'll overwrite. So I guess if you're trying to, I'm sure there's another option you can pass to where it won't overwrite or something like that. I just don't.
Something plus or something like that.
Yeah, something like
So
that.
you can't like actively edit a file with this method. You're writing the whole file and it's saying I'm done.
Right. You would have to do like WR to read the file in, and then you'd have to do a little bit more complicated to actually read the file, and then where you are in the file, write or whatever. If that makes any sense at all. That's a little bit more complex. But I don't think you guys will have to do that in this class specifically. Another cool thing you might want to know, when you want to you saw how if we go back up here, and also if you guys need to leave or whatever, I'm not going to hold you here. I want to stay here as long as you guys want to stay here. Okay.
How much do you have left to cover?
Just a little bit longer in the C file, and then a little bit, the make file is much shorter, explainer. I can run through that pretty fast.
Is this going to be available like on Canvas?
Oh yeah, I have a GitHub repo. I'll send it in the Discord and on Canvas as well if you guys aren't in the Discord. Hopefully you guys are all in the
I
Discord.
appreciate that.
Yeah, of course. Okay, if you go back here. So it's just a little bit longer in here. I just wanted to try to cover everything that you guys are going to run into. And some neat stuff. So we saw that we were using printf, so that's file printf, so you can use the same sort of printf thing, but printing into a stream. And printf, the function that you sort of interact with a lot of the time, is just a wrapper around fprintf that just passes standard out, which is another Linux thing. Every program in Linux has a standard in and a standard out. That's like that's the initial Unix thing of the great revelation, is that you could pipe programs together with their inputs and outputs or whatever. And so every program in Linux and even any Unix-based thing is going to have a standard in and standard out.
Standard in would be the keyboard.
It could be anything. So a lot of times you'll have memory mapped standard in. So you're saying I'm going to write to this program standard in. The program is going to map their standard in to some sort of memory address. You're going to write into it. It's going to read the memory. So it's kind of interesting. So you might hear something like everything in Linux is a file. So like this might be a digression. Let's try to go through this. Okay, entry point. So if we go back to the main, you'll see that we receive 2 arguments, which is kind of interesting because if this is the function's entry point, who is passing arguments to us or whatever? And it's actually the operating system, well, the C standard library, then the operating system or whatever. And we're getting basically the argc, which is arg count, how many arguments you get, and then argv, which is an array of strings, so a pointer to a pointer of arg values or whatever. So if we compile this and then we run program.x with like some, dummy .x with foo and bar, and we run it, it's going to, according to this, print every argument that we got passed. And you'll notice that the first argument is the executable's name. So it's just something helpful to remember. Args begin at 1 if you're actually doing something with them. I'm trying to go a little bit faster here. So you can imagine doing something a little bit more non-trivial with arguments. So you might say that we're going to allocate a buffer that's known at runtime by the user how long it is or whatever. So we'll say we're going to allocate 10. We're going to say the first argument is 10. We do that. Go through here, blah, blah, blah. Am I going too fast or should I? Okay. All right. And A2I, that's for ASCII to integer, is going to interpret the string that you get passed in as an integer and return the integer. It's a little bit, if it doesn't really matter for small programs, but if you're doing something more complex, you'd want to do something different. Okay. Cover header file, most of the other. Everything else is kind of like you expect in other languages. If else kind of functions a lot the same. Switch statements, if you've had that, and I think Python has that now. I'm sure lots of languages have that. Very useful. A lot of those things are the same. And again, if you have any other questions, ask me. I'm always willing to talk about C. Are we good with the C portion? We can move on. Okay.
What's the difference between malloc and calloc?
So it's gonna. So calloc, if we go back to calloc, if we just gonna comment this line. Oops. So malloc will take in just a amount of bytes or whatever. Calloc is going to say how many of something and then the size of that something, if that makes sense. So it takes in 2 arguments.
You're saying most of the time we use malloc, we're essentially doing a multiplication in there. So
Yeah,
we're
like
doing
it-
what calloc is doing.
Right. And then malloc will give you uninitialized memory. Calloc will zero out all the memory that you get.
So in a way, like calculating the
Yeah.
memory you need, and
Yeah.
malloc is already there manually.
Yeah, exactly. Okay. So we'll go over, I'll try to get through this because I know it's an hour. You guys probably have places to be. Okay, make files. So again, C is like a committee language. It's the future of the language is decided by literally a committee called the C committee. So there's no company in charge of it. It's just like a bunch of nerdy people saying I think it should be like this, and they argue over it or whatever. And so there's no official build system. So if you run a Java program, there's Grodl or whatever. There's all these other things. So in C, people will use CMake or make. We're going to be using make, which is GNU. So if you heard GNU plus Linux or whatever, it's the same people who made make. Make is like to think of it as just one file where you have a bunch of little shell scripts that you can just call with these targets or whatever. So let's say we have a target called build, which you've seen that I've been kind of having to go and let me recompile and then let me run or whatever. So now we have this rule, or this target, I suppose, that basically does the build for us. We don't have to remember all the flags. You can imagine, like, if you got on a really complicated project, you're passing a lot of flags to your compiler to, give me extra warnings, give me, sanitize my addresses, all these other things that you might be doing. So, you wouldn't want to have like some guy just like, oh, if I remember correctly, here's the compile, command or whatever. You just put it in this build file or this build target. So if we run make, the first target will run if you just type in make, and it'll print out what that thing is. And obviously we get exactly what we expect. So if we want to do, say we want to chain together a couple different targets, we can do another target, and then we add the targets that we want to run before this one. So this one is like the end of the chain, and this one comes before it. This one will run before this one. Like build will run before run.
And then if you had another one, if you spaced after build
Right.
will be the first one that's running?
I think so. I think it goes left to right, if I remember.
And then the leftmost one.
Right, left. I think leftmost to rightmost is, I think. I can't exactly remember, but I believe. So, okay. So we do that, we say make, and then we just type in literally the name of the target we're wanting, and it runs the program. Obviously, if we had the program actually doing anything, we would see its output. But I don't prefer to do it this way, but you'll see this a lot, where you will have object. So I don't even know how to explain this. That's not just stupid and confusing. So object files. Have you guys heard of that before at all? Okay, object file. That's just. So you might imagine that we've just been having a program that has just one entry point and maybe a couple functions, and it's all in the same file. If you wanted to have a bunch of files, or maybe you're linking with a library that someone else wrote and you're wanting to use their stuff, they could compile their functions, even if it doesn't have an entry point or like a main or whatever that is actually a program. It's just a collection of functions. They would compile theirs into machine code that you could then reference in your own program, if that's not confusing. So that usually is, well, I wish it was simple, but people are stupid and make it complex. So main.o object just means this is machine code. So we have rules for, oh God, I just wouldn't recommend, but you'll see this all the time. For each little file, you'll have a rule to make that file, to compile that file or whatever, which will take in, you can specify files also as dependencies, which make of that what you will. So we have these two rules to compile these two files, and we have this program, I keep saying rule, but I should say target that depends on these two files being compiled. We then link them together with these. We add these object files, which again then get pulled together and linked into -o program, if that makes sense. So if we do make program, I need to actually create util.h. Like I said, I don't recommend. Oh God. I don't recommend. Because this is all like trying to solve like the incremental build system where like, oh, I've only modified this file and we have 7,000 files. I don't want to recompile every single one. I think that leads to more bugs than it solves, or like than the time solves. Maybe on like if you're working on like the Chrome browser.
Or something?
Sorry.
Can we use like CMake or something if we have like a lot of files, or are we just
That's one way. Like CMake is basically a build system for build systems. It wraps around Make. So like if you're on Linux, it will wrap around Make. If you're on Windows, I think it will also wrap around like Visual Studio Solutions. So obviously we're all programmers, so the obvious answer to like this sucks is to basically take a big wrapper around the ball of poop and say that it's solved instead of solving the problem. So
Slightly larger, maybe less than
yeah, okay. So we do that. You can also, it's very much like a shell script, so you can have little variables. So maybe you want to separate, be able to change which compiler. So maybe you want to use GCC on Windows, or on Linux, you want to use Clang on Mac or whatever. So you want to have that as a variable that can actually change, so you don't have to re-edit every single time you ever call the compiler. You can just change it in one place. C flags, say which flags you want to use, blah, blah, blah. Source files, this is actually kind of useful. You can declare all the source files that you're actually wanting to compile into your program. I would actually recommend doing something like writing a script or whatever that just collects all the files and not manually typing them out or whatever. So we do the same thing. We build with variables, make, build. If your shell is good, it should autocomplete these targets for you, and it does what we expect. Okay. Yeah, see, we get all the flags that we wanted, we declared here. And then one last thing, make is really just, again, I think it's just a group of shell scripts, so you can plug your own shell scripts into this and then call them from your make system. And you'll actually, I think the first lab will have a little bit of that. Run script. And it will run this count lines script here that I wrote here. It will call this right here. If we go and open the make file, it calls it. Well, I guess I should remove that. I was just testing. But it'll call that script and actually run it, if that makes sense. Okay, I think that's all I had planned out. I'm sorry if that took too long or whatever. Okay. Is there any questions or anything, or you guys want to get out of here?
I have a question. So if I use like an example like this resource and like I don't know, as a reference to implementing.
I don't. I mean, just maybe
it says
source
I need
it.
to like document it in the homework.
I mean, just maybe put a link or whatever. Obviously, you're not gonna. I don't think I'm expecting you to write bubble sort from scratch or whatever just from your top of your head. If you, I mean, yeah.
So it's just like have the links.
Yeah, have the link. Whatever. I don't. It's not really that big a deal. Okay. Thank you guys for coming. Yeah.
So do you know if we're going to be doing all this stuff on like the GPL machines or?
I would say if you can, just for convenience sake, if you can develop on your own and then maybe test on GPL. We're supposed to test you guys' stuff on the GPL, but I don't really feel like copying from my machine over to the GPL every time I want to test one of you guys' stuff. So I'm probably just going to run it on my own machine. So if it runs on any Linux,
It runs on my machine, trust me.
So basically, just do the homeworks and then download the latest Linux stuff?
Yeah, just keep it simple because the class asks a lot of you, but it's more of like, did you attempt it? Did you try? Did you try to learn something new? That's what I felt when I took the class, and I want to continue that feeling.
Appreciate it.
Is that the environment that we'll be working in?
No, you can use any editor you want. Yeah, just whatever you feel most comfortable with. Just as long as you can, use make script or make files and edit text.
What's the difference between NVim and then Vim?
NeoVim just has like a bunch of Lua stuff added on top, so you can configure your editor with Lua instead of Vim script or whatever.
Okay.
I think that's the difference as far as I can tell.
Because I just started learning how to use Vim.
Yes,
That was interesting.
awesome, yeah.
All right, cool. Thank you.
Yeah.
So for the TOR file that we're gonna submit for like the homework, it's just gonna have three things, right? It's just gonna have the test,
Mhm.
makefile, and the program.
Yeah, each,
Okay.
yeah.
Okay.
As long as you follow the template and, it runs and I'm
So I should delete like the output file. That's not.
I mean, the make file it'll probably overwrite the output file, and I don't really care as long as I can run the run all whatever,
Okay.
and it runs and it's fine.
Basically, the makefile, like, just make sure that one is.
Because there's 112 EU, so I'm not gonna have the time to really
Debug.
yeah.
You want to push run it not
Yeah.
as the TA.
Yeah.
You don't want.
Yeah, exactly.
How are you taking out participation points?
I tried to do attendance, but I'm just going honor system. Don't abuse that. But if you were here and I kind of recognize your name or your face, I'll trust you that you were here.
So like,
I'll probably if did he say that you're going to get participation points if you come to office hours?
he said, yeah, if you can't, yeah, but he can't like stack them. Like if I came here, I can't get 2 points from going off.
Okay. I guess if you try to get participation points again during office hours, I'll probably keep track of that. But it was just there's way too many of you. I didn't realize all of you guys were going to come, so it's just honor system for this occasion. Whatever. That if you say you came, I'm going to trust you and say that you came. Which obviously it's not a problem for you guys because you all came.
Is the officer mentioned in the syllabus or the content?
We have not, because we're still trying to we're trying to get our lab stuff scheduled.
Okay.
Once we get that scheduled, we'll have office hours. I believe Dr. Veris's office hours are scheduled already. It's just the us TAs, we haven't scheduled ours yet, which hopefully that'll be soon.
I had this like all night been struggling for a while. How do you uncomment lines in this functions?
Oh,
I manually I'll have to hop off of. I just go to normal and I just manually highlight and then just command.
Yeah. It should be GC. Like if I go, let me go back here. Let's see. If I go Shift V and then I go GC, you can also do just one line GCC. That should, I believe. I don't think that's a plugin I have.
Okay.
I think that should be native.
And then also another thing is I've also wondered how do you indent lines? Because I do shift. Once I highlight the lines, I do shift. I think less than or greater than.
Yeah, that's what I
do.
do.
Repeat it over and over because I would have to re-highlight everything.
Yeah. That's actually.
Instance.
I have my whole NeoVim configuration on GitHub.
So you had to configure that. I didn't know if there had.
Yeah, let me just find it.
Because I was wondering if there was something that we can just repeat your last motion, similar to how when you do F, you can just do the semicolon to repeat.
Yeah, I believe if you do, I guess it's not dot repeatable, but let me find it. Because it's actually a simple little fix. Config, and then there's options key maps. It's just this right here. That'll make it. Or no, that's not it. What am I looking for? Oh, here we go. That's all you have to do to get that to where it will unselect your highlight. Yeah.
That makes sense. Well, not for thank you.
Yep.
What's the Vim
Not for the ones that don't use it.
The Vim session? I don't know. Do you guys actually want another session? Because I don't mind doing these.
I wanted to.
Well, I don't know.
The last time I tried installing NeoVim, because I was on my Windows, I tried using WSL. I don't know if my GPU or whatever supports virtualization, but I don't know if my PC can even do that because I built it a while back.
Oh yeah.
So it just crashed every time I tried installing any InVim. I tried using LazyVim or the other one. I think the more recent one was just ChadVim or something like that.
Oh yeah.
It basically pre-configures everything because I was too lazy to go into it just kept crashing every time.
Yeah, this is something I've built up over a year. It's all just a couple plugins that I really need, but I try to keep it simple because when you're editing, if you ever have to edit on someone else's computer, it's kind of difficult to be used to your own very hyper-specific configuration or whatever.
Actually, your program shouldn't discriminate against.
Thanks.
Yeah, no problem.
Maybe
Yeah, what was your name again?
Sid.
Sin. Okay. Yeah, nice to meet you guys.
I got a question.
Yeah.
So, I was doing the post part
Mhm.
of the assignment. I think I basically, I was just asking like grading wise, because, so I run my, like my test coverages,
Mm-hmm.
and I get 100%
Right.
on everything. And I know that's one of the requirements, but
Mhm.
are you guys just gonna run our test to make sure that our tests cover 100% of the program, or like how does that work?
I mean,
Like, are you guys just gonna run C?
I'm probably, well, it depends on how rigorous I'm trying to be. Probably not, but I'll probably just do, /run all, whatever. And if it gets above 90% coverage, I'm gonna give you full points.
Well, I spent an hour trying to get it from 95 to 100%.
Because when the TA, when I took the class, counted off for like 98, and so I'm not gonna be that guy.
Okay, and then, so, like for the program,
Mm-hmm.
like isn't for at least the sorts everything almost the exact same? Because we're getting the same exact input file? Except the only thing that'll change is
Yeah,
just
the only
sort.
thing that'll change is the sort, yeah.
So like, are we kind of good to just copy like our file?
Oh, yeah,
Well, just make
that's no worries.
Could we
about
just have like I guess on the thing it says not to, but I make a folder just called test and just store all the tests?
that. Sure, I don't care.
So you don't have to copy it all over.
Okay. Dang, bro, I
And
can't.
as long as the ./runall.sh works,
Yeah.
I'm all good with
Wait,
it.
what is that?
That's like the top level script or whatever. Should be like at the very root of the directory. I think. I can't remember. I haven't looked. Maybe. Like this.
Do we
right
have to
here.
worry about that make I stuff? Because I
don't even remember what that does.
It said something about
We
it
have
keeps,
to.
it keeps the program running even if it fails or something.
Oh, I think that's -I for ignore errors
Yeah.
or whatever. I mean,
But, like, everywhere I
hopefully,
look-
if your thing works, it wouldn't matter anyways because there's not gonna be any
It's
errors.
because everyone was looking, I was like, I don't really see much stuff about make I. Everyone just does the make command.
Yeah, so like, that's just there for like, if you have an error that comes up, like if one of your scripts or one of your steps fails or whatever, errors, it will stop the whole make file or the whole make system or whatever. If you do -I, it'll just continue running. It won't like stop the whole make system or whatever.
Okay. So that's something else. Oh wait, yeah, where's that run all thing? Like, can I just
Should be-
type it in here, like make something, make run?
Is it, are you at the, maybe CD backwards to just the problems directory? Yeah, and then do like ls. Should be /run all.
Oh.
Yeah, that one. And I think that all that does is just runs the make file in every directory.
I don't know like that. I don't need that permission for it.
Oh, and you'll also, I wish I would've, if you ever see like permission denied, it just means there's file permissions for every file in a Linux, whatever.
Yeah.
If you do chmod chmod +x, which is saying add executable privileges and then the file name. I'll put that in the Discord because I'm sure you guys will run into that.
Okay. And then for the memory leak stuff,
Mm-hmm.
why is it so small? Oh, I'm not even gonna go right. So I don't know if I was even doing anything, because I
Mhm.
get like.
Yeah, as long as, all heaps blocks are free
Yeah.
and no leaks possible. That's what we're looking for.
But then I got like suppress 0 from 0. I don't know if it was like I'm doing nothing. Like I don't know if it meant like I'm suppressing 0 because I'm not doing anything.
I don't think so. I think as long as it says all heaps blocks free, that just means that there's no
Okay.
possible, there's no detectable memory leaks.
Okay. Well, that's all right, I think.
Yeah, no problem. You guys ever have any other questions?
No.
Alright.
I was gonna ask if you compete competitively in lifting, but that's how you're just profile.
Oh, I did for my second semester, my sophomore, and then my first semester of my junior, and then I was not very good at it, so, yeah.
Let's see, what was the most that you got up to?
I did, at my last competition I think I benched 275. I think I squatted like, because it's all like, kilograms, so I can't remember the exact. It's like around 405, and I thought I was pretty good at deadlift. I did 517 or something for deadlift.
Ooh, pretty good.
It's not bad.
Is it like, if you're still at it, you figure you go training sometime?
No, I still do lifting or whatever, but I just don't compete. Yeah.
Okay.
Do you go to like brew house or whatever?
No, I just go to like Rep Republic down like Midtown City.
Oh, okay.
Yeah.
Yeah, I just do Sarkies. I'm lazy.
No,
I'm already here.
And it's free, so.
Yeah, true.
All right, well, don't let me hold you up, Mitchell. I know you got questions.
Just one question.
No, you're good. All right, see you, Spencer.
Yeah, see ya.
Sorry, I didn't want to.
Oh, no
I
worries.
don't know if you have a lot of time. Okay. So I'm just. How do you make test cases? Like, I mean,
Right.
I've tried to think of a lot of scenarios, and I can only
Mhm.
get it up to 88%.
So if you go to open up one of the files that are generated, because one of them will show you which lines are actually not being run. Which is, I wish he would have told you that. 'Cause
Is it this? How much?
I believe it's one of them. Maybe, I think, yes. So yeah, if that means it's not,
Okay. Oh.
yeah. So, for something like that, you could do like a test case where it's like you have the output file as a directory, because then you can't open a fopen on a directory, or
Yeah.
like fopen on like a privileged file,
Mhm.
whatever, if that makes sense.
Yeah. Okay, that makes sense. Like, that makes things a lot easier.
Yeah.
Second thing is like, is there a way like I can automate this to where I don't have to go, like every time I've been
Yes.
like, this is what I've been doing. I've been running the program
Mhm.
and then running this val grind,
Mhm.
which was in the directions,
Mhm.
and then I'm running GCOP to
Mhm.
make sure that it actually.
It
is that-
should
is there
be-
a way to.
I hope, I can't remember, it's because obviously I haven't looked at this too deeply. You would do something like this, where you have in the make file for that directory, you have all your test cases here.
Okay.
So then when you want to run for all your test cases, you just do the make, and then either the coverage tests or the leak tests.
Okay.
Does that make sense?
So
you'd go
would
back.
would I have to just adjust this make
Right,
file?
you would add extra test cases here.
Oh.
Does that make
okay.
sense?
Mhm. Okay. All right. Yeah, that was about it.
Yeah, no worries.
I was like, oh man, like we have so many assignments already due. Like,
Yeah.
we do one Sunday. Two on
That'll
Monday.
kind of taper off, if I remember correctly, and I'm hoping it should be kind of a lot, and then it'll kind of taper off, because once you guys get into the labs, usually he has mercy and kind of stops with the other things a little bit.
Mhm. Yeah, I'm trying to finish everything for Monday because it's Labor Day.
Yeah.
So- all right. Well, I appreciate your help.
Yeah, no worries.
Thank you.
Yeah. Mitchell?
Yes.
Okay. Nice meeting you.
Nice to meet you too.